Okay, we are starting a new section in your notebook. That means your table of contents needs to be updated. This is section 2.5. It is called implicit differentiation. Okay, differentiation is just a fancy word for derivatives. So you know exactly what that means. It's just a long fancy word. Okay, implicit is the new thing that we're going to be talking about. So if you haven't updated your table of contents, please pause the video. Take a second to do that. So first, to understand what implicit differentiation is, we need to understand what an implicit function is. Well, there are two types of functions, implicit and explicit. Okay, so what are these? Implicit means you cannot easily solve for x or y. So you're not going to get y, all your y's on one side and all your x's on the other. That's not going to happen. Okay, this is a new kind of function. We have not looked at these yet. Okay, explicit is you can solve for x or y. This is usually what we see. Okay, so all of our f of x equals blah, 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 our y equals whatever, these are all explicit. So like there is an explicit thing that is happening. Here's the relationship of y to x, done. Okay, implicit, x and y's are going to be all jumbled together. So we need a new process for taking a derivative because our old process won't work here. So what's going to happen, before we look at the example, okay, so remember when we take the derivative of y, we write, our notation for that is dy dx. Because what's happening is it's the derivative of y with respect to x, okay? So it is the derivative of y with respect to x. So when we take the derivative of x, we haven't had to write this before, and technically you don't, but I think it's going to help you understand. The derivative of x is the derivative of x with respect to x. For one problem, the with respect to part does not change. So this is just the derivative of x with respect to x. Dx over dx, the same thing over the same thing is 1. This is not necessary. Okay, but dy dx is because it doesn't cancel out. Okay, so let's look at a problem and look at why we needed to know these things. So this is an example of an implicit function. All of our y's and all of our x's are all on the same side. Okay, it's not already solved and it's not going to be easily solved for. So this is an explicit, or implicit, I'm sorry, explicit is what we normally deal with. Implicit is the new. This is an implicit. Like explicit is explicit directions, step 1, step 2, step 3. Implicit is like we had a conversation and you had to figure out what the directions were. So when we take the derivative, so remember our operation for taking the derivative is d over dx. We're going to take the derivative on one side of y cubed plus y squared minus 5y minus x squared. And on the other side, we're taking the derivative, d, just d over dx. So notice the difference between all of these things. The d over dx means, hey, take the derivative of this. Just like if we wanted to multiply both sides by 2, we'd write a 2 on the outside of those parentheses. We haven't actually taken the derivative yet. After we take the derivative, we're going to have one of these. Okay? So our next step is actually to take the derivative. So we have y cubed. So we use our power rule. We get 3y squared. What did we take the derivative of? We took the derivative of y, so dy, with respect to x, dx. So we're going to write that every time we take the derivative of y. So plus, we use our power rule. Bring the 2 down. Y is left. We took the derivative of y. Derivative of y, not x. With respect to x. The next one, we have negative 5y. So when we take the derivative, we just have negative 5. We took the derivative of y with respect to x. So we're going to write that again. Okay, all these technically are times. Now we have minus x squared. So the derivative is 2x. This time we took the derivative of x with respect to x. Then we have equals. We're taking the derivative of 4, which is just 0. There was no x and y. You can put dx down there because technically it's implied that that's an x value, but it's times 0, so it's going to go away anyways. Okay, constants always derivative is 0. So from here, well, let's look at a couple things that can happen. Dx over dx, that can cancel. That's just 1. So 1 times negative 2x. What we want to do is we want to add or subtract terms that don't have dy dx connected to them to the other side. The only one that doesn't have dy dx connected to it is right here. So we're going to add that to the other side. So we're going to have equals 0 plus 2x is just 2x. Okay. And then we want to, on this side, we have 3y squared times dy dx, 2y times dy dx, and negative 5 times dy dx. We want to get dy dx by itself because our goal in all of these, OAL, is to find dy dx. Have dy dx be by itself. Okay. So what we want to do is factor these out. The dy dx, we want to pull them out all into one spot. So we can write this as dy over dx times 3y squared plus 2y minus 5. Because if we factor dy dx out of here, it's gone here and here, and we're just left with these 3 things inside of the parentheses. Okay. Then we want to, right now this is multiplied, dy dx times 3y squared plus 2y minus 5. So to get rid of it, we just divide it, 3y squared plus 2y minus 5. It's long, but it's what we want to get rid of. So we're going to divide by the whole thing on both sides. Okay. Here it cancels, so dy dx equals 2x over 3y squared plus 2y minus 5. Okay. And that's your answer. That is your derivative. We know this because dy dx is all by itself, and there are no dy dx's on the right-hand side. Okay. So first we took the derivative and we put dy dx in there. We found out dx is not important. Okay, technically it's there, but it's just 1, and times 1 doesn't change anything. And then we solved for dy dx. So let's do another example and see if we can do this again. So we need to take the derivative of x squared times y plus y squared times x equals negative 2. So on both sides, what we're doing, we're going to take the derivative of x squared y plus y squared x equals, and we're taking the derivative of the other side as well, negative 2. This step is not necessary, but if you're forgetting to put dy dx in there, or if you're forgetting to take derivatives of constants on the other side, it is important. Okay, so this first one, be careful here. These problems do get long, so just because your answer is long does not necessarily mean that you are finished. So x squared times y, that is a product rule. So when we take the derivative, we write down the first. I'm going to write down x squared. I did not take the derivative of that, so I do not need to write dx dx. So our product rule is the first times the derivative of the second. The derivative of y is 1. I took the derivative, dy over dx. Okay. So this is first d second plus second d first. I'm going to write y. I did not take the derivative. I just wrote it. So I'm just writing y. First d second plus second d first, so times 2x. I took the derivative dx of x with respect to x. Okay, so this was our product rule. I'll write it in parentheses. We did first times d second plus second times d first. All right. Then we have a second part. We're not done. We just did the product rule with the first one. So we have plus, we need to take the derivative of this. Again, it is a product, so we're going to use our product rule again. First times d second plus second times d first. So I write the first, y squared. I did not take the derivative, no dy dx. D second, so derivative of x is 1. I took the derivative of x with respect to x. Plus the second x, I did not take the derivative, no dx dx. Derivative of the first, so derivative of y squared, 2y. I took the derivative of y, dy dx. And then I have equals, the derivative of -2 is just 0. Okay, so I'm going to simplify this, multiply things together if I can. So times 1 doesn't change anything, so I have x squared dy dx plus 2xy. Dx dx is just 1 plus y squared. Dx dx is just 1 plus 2xy. That one has a dy dx. Equals 0. Now add or subtract. Everything with dy dx goes to one side. Everything without goes to the other. So this has dy dx and this has dy dx. So they will stay. X squared dy dx plus 2xy dy dx. I'm going to move these, so I need to subtract these two. -2xy minus y squared. I factor out dy dx to get it by itself, so dy dx times x squared is left in the first one, plus 2xy in the second one. So -2xy minus y squared. Divide both sides by all of this, x squared plus 2xy, x squared plus 2xy. So my final answer is dy dx equals -2xy minus y squared all over x squared plus 2y. All of that. So implicit differentiation usually does give us a little bit of a longer answer, okay? But our steps that we followed. So we're taking the derivative, and we have to make sure that we're using dy dx. And then we solve for dy dx. Those are our two steps, basically, okay? So just be careful when you're walking through. We will continue 2.5 notes tomorrow, okay? So this is not the end of the section, but we are going to use the rest of today to practice.